Okay, it's time to finish up. You may have noticed that I did the wrong problem in the last video and I called it 40, I think I called it 40, and it was actually problem 41. I have added 40 to the end here. I didn't want to forget it. Another good factoring problem. So we'll just pick up with 43 and work our way over to those last few problems there involving rational exponents and of course good old number 40 there. Use the factor theorem to find the factors of t to the third plus t to the second minus 2t. Now, the factor theorem pretty much says a polynomial f of x has a factor x minus k if and only if f of k is equal to 0. I don't think we're really using this theorem here. I think we're just going to go ahead and factor this guy out in a traditional manner. Okay, the directions threw me off a little bit there. So we're going to factor t to the third plus t squared minus 2t. The first thing that you always should check for, and I don't always say it out loud because I kind of do it in my head, is I always check for a greatest common factor. And I think we had a couple other factoring problems where the greatest common factor was 1, so that was of no significance. But here, I have a factor of t. So I factored the t out, kind of like doing the distributive property in reverse. T out of t to the third leaves t squared, t out of t squared leaves t, t out of 2t leaves 2. And then I have a trinomial that remains that may or may not factor, and this one does factor. This is t plus 2 times t minus 1. So, of course, I don't have my paper in my hand. Let me grab that. According to the paper here, I think I have just found, yes I have found answer C. Okay, what is the third term in the expansion of x squared minus 2x quantity to the fifth power? Excuse me, x minus 2, let's try that again. The quantity x minus 2y quantity to the fifth power. Alright, this is the binomial theorem, and you may have noticed that I already have part of the Pascal's triangle drawn out here, because it's useful to use this to go along with the pattern of the powers of the first and second terms here. Now, here's one thing that, you're looking for the third term here. The signs are going to alternate because of the minus. You're going to start out with a plus, then you're going to go with a minus, then you're going to go with a plus. The third term is a plus, so I already know it's positive. And then, I've got the exponent of 5, so 1, 2, 3, I've got a 10 right here for my part of my coefficient, one of the factors of my coefficient. And now I'm going to have powers of x and powers of 2y. I don't need to worry about the negative. I already know it's positive. So what powers? Well, we start with the first term has the highest power, so it'd be x to the fifth, x to the fourth, x to the third. So this is going to be to the third. And remember, whatever this power is and this power is, that has to add up to 5, so that means this one's a 2. Or remember, you're starting with 0 on the end, so that's 2y to the 0, 2y to the first, 2y to the second. So now I have 10x to the third times 4y squared, because I square this, and then I multiply the 10 and the 4, and I get 40x to the third, y to the second. Now, some students have trouble with that. By the way, that matches answer A. Some students have trouble with that, or maybe they don't answer for a particular term. Maybe they want you to expand it. You can always expand it using all the coefficients. It's a lot of work, but you can always expand it that way to make sure that your exponents are lining up. If you use the pattern that I just kind of showed you, and you might have to kind of replay this a couple of times to pick up on the pattern, you can find it. Now, it's very similar to this guy up here, so we're going to be doing the same problem again here, only this time it says what's the third term in this expansion, and it's to the sixth power, the quantity a minus 2b. So now I'm using this row. And I want the third term, and the third term there's a 15. Now remember, the signs are going to alternate because that's a minus. If it's a plus here, they're all positive. But if it's a minus here in the middle, they alternate. Plus, minus, all the way down. Plus, minus, plus. Again, the third term is positive. So I have a positive, I have a 15 from here, and then I have the powers of A and 2B. Or not to be. So we always start with the highest and work our way down with the first term. That'd be the a. So this would be a to the sixth, a to the fifth, a to the fourth. So this is going to be a 4 here. And remember, these two factors have to have exponents that add up to 6. So that's going to be a 2 there. So this gives me 15a to the fourth, and that's 4b squared. So that's 60a to the fourth, b to the second. And that should be my guy right there. And let's see if I can find him. There he is. It looks like it's answer D, although it's hard to read on my copy. Hopefully I'm matching up here. All right. Should know Pascal's triangle, how to create it for problems just like this, or if they want the entire expansion. But remember about the little trick with the side in the middle. They're going to alternate. Plus, minus, plus, minus. All right. Now, what kind of function does this table of data come from? The best way to do this is to look at the differences with the y values. Now notice they're all in order. For the x values, you take the differences, consecutive terms like this. 11 minus 2 is 9. Always right minus left if it's written this way. If it's written up and down, then it's bottom minus top. But right minus left, 21. Right minus left, 39. Ugh. Right minus left, 63. Right minus left, be careful, 93, I think. Ugh. Hopefully I didn't mess up with that. Check with your calculator. Well, these numbers don't match. If these numbers match, then this would be linear. But they don't, so now I do another difference. This is 12, this is 18, this is 24, this is 30. These numbers don't match. If they did, it would be quadratic. Linear, then quadratic. So let's go one more time, at least. So the common difference here, right minus left is 6, right minus left is 6, right minus left is 6. There we go. That means this is cubic. Linear, quadratic, cubic. And is that a choice? It better be a choice. It is. It's answer C. C for cubic, I guess. All right, now we get to some problems that don't take as long to work, but very easy to make silly mistakes. The first thing I have is I have a square root of the expression 64x to the fourth y to the sixth. When you take a square root, now again, even though the radical sign doesn't have an index written there, it's kind of like there's a 2 for the square root, although most people don't write that down. You look to see the square root of each factor, the 64, the x to the fourth, the y to the sixth. Well, the square root of 64, that's nice, that's 8. 8 times 8 is 64. The square root of x to the fourth, do the little division trick. 2 goes into 4 twice, with none left over, twice. So I take out an x squared for twice. If I had something left over, then it would stay in the radical. Not the case on this problem. If I go 2 into 6, it goes in 3 times, evenly, 0 remainder, so I would have a y to the third. Now, the directions will most likely say, assume that the variables represent positive numbers, because if they don't represent positive numbers, I would have to put absolute value bars around the y to the third, because I don't know if x or y is a positive number or a negative number. Since they're raised to even powers, it's positive. But when I'm taking the root, this is the principal square root, I would have to make sure that my answer is positive. Now I don't have to worry about x, because whether it's positive or negative, when you square it, it's positive. But I would have to worry about y. So you have to assume, since the directions don't say it, but there's no answer in there with an absolute value, that you're going to be okay here with answer C. 8x to the second, y to the third. Now, what happens if instead of it going in evenly with the remainder 0, what happens if, let's say for example, this is a 7. 2 goes into 7 3 times with 1 left over. I would have to leave the 1 left over inside. The remainder number of factors goes inside the radical. But that wasn't the case here. Just be on the lookout for that. Alright, next guy up. I have negative exponents. This does not mean that it is negative. It just means I have a negative exponent of negative 1/2, 16 to the negative 1/2. Remember that x to the opposite of n is 1 over x to the n. So this is 1 over 16 to the 1/2. Now the 1/2 power, the denominator of the rational exponent, is the index of the root. It's a square root of 16 to the first power. This is the square root of 16. Well, that's 1/4. And 1/4 is, I hope, a choice. Looks like it's answer D. Now I evaluate 9 to the 2/3. Here's where that rational exponent comes into play, and there's my index. So this is going to be the cube root of 9. Is this a cube root or is it a... Maybe that's 3/2. Okay, let's write that as 3/2. I can't read this print very well. Let's say that's 3/2. So this is also, sorry about that, square root. The square root of 9, the principal square root of 9, and it's being cubed. This is the same thing as the square root of 9 cubed. Because 3/2, see, 9 to the 3/2 can be thought of as 9 to the 1/2 cubed. Because a power to a power, you multiply the exponents. 3/2. And that's the square root of 9. Of course, the square root of 9 is 3. 3 cubed is 27. And with that way, you do match an answer. It's answer B. That's provided that that's a 3/2 there. My print is not very good. I thought it was 2/3 when I wrote this down. All right, number 50. Kind of saved a good one here for the end. Notice the negative exponent, just like this guy. This is 1 over 16x to the negative 4y to the second to the positive 1/2. All right, you have, just look at the denominator for right now. You have a product of 3 factors raised to the 1/2 power. Each one gets raised to the 1/2 power. Well, the 16 to the 1/2, that's the square root of 16. X to the negative 4 to the 1/2, a power to a power, I just mentioned that, you would multiply the exponent. So negative 4 times 1/2 is negative 2. This is x to the negative 2. And y to the second raised to the 1/2 power to a power, that's y to the first. Don't leave your answer like this. They're not going to want an answer with a negative exponent, okay, because that means it's a complex rational expression. X to the negative 2, I'm going to bring him, he's a factor, I'm going to bring him up here as x to the positive 2. So that gives me x squared on top and a 4y on the bottom. And hopefully that matches one of the answers. It looks like it matches answer A. All right, now the problem that I skipped, it said, what are the factors of y to the third minus 4y? Here's another GCF. Like this guy had a GCF back here of t, this guy has a GCF here of y. I'm going to factor the y out. Always, always, always check for a GCF when you're factoring. If the GCF is 1, fine, but you got to check. So this would be, if I factor out a y, it's like distributing in reverse. I get y squared minus 4. You divide a y out of y to the third, leaves 2 factors. You divide a y out of negative 4y, leaves the negative 4 minus 4. And as we've seen something like this very similar, this is a difference of squares. This is going to factor into conjugate binomials. A y and a y, a 2 and a 2, one's a minus, one's a plus, it doesn't matter which one goes first. And I don't know which one this is. Let's see. I've got so many papers in front of me here, I don't know which one letter-wise is the answer. I don't know if we'll be able to read it off the actual page here. If I can find number 40, which right now I can't find number 40. There's 42. Well, you may have to trust me on this. Let's see. Oh, here's number 40. All right, that looks a lot like answer D. Whew. Got it. Okay, I hope this review helps. Remember, with multiple choice, you can work backward. Now, if it turns out the exam's not multiple choice, then, scratch that. You're going to have to know the direct way of doing it. But if it is multiple choice, and a lot of times exams are, just due to the time constraints of grading, then remember that you can work backward on some problems. If you get stuck on a problem, skip it. Go on. Budget your time wisely to make sure you finish everything. Then come back and get those answers in. Keep an eye on the clock. Budget your time wisely. Scratch paper, pencil, have all that stuff as well as your calculator, if the calculator is allowed for the exam. And knowing some of these problems, it would come handy. It would come in handy on a couple of them at least. I did have to do one long division, as I recall. So study, 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 study. All right, with a little practice, you'll be prepared and hopefully confident to take your exam.